Hello everyone, today we are going to explain a law of large numbers. It's actually very simple, but I want to make a video about it. What is law of large numbers? Let's say we have a population and this population contains the height of people. We have a population and we have a data set that contains the height of each people in this population. And let's imagine that this population, this data set contains all of the individuals in the population. And let's say our population is very small, 1.8. And what is the mean of this data set? And 1.8 divided by 4. So 4 plus 1, 1, 8, 1, 1, 1, 8, and 2, 2, 6. And 2, 6 plus 4, 2, 6 plus 4 is 6, 6. So it's something like 6.5 divided by 4. But in real life, in our example, our data set is very small, so we can actually measure every individual out of the population. But in real life, that's not the case. In real life, there are millions of billions of people that exist in the population, and it's not possible to measure the height of all of them. So what we do exactly here is that we take a random variable. We take a sample out of this data set. Let's say it's 1.6. And we denote the number of sample with n. In this case, n is 1. And we take this 5, and then we take another one and 2. Let's say we took 1.6 and 1.7 divided by 2, and we take 3, 6, 1.7, and 1.8 divided by 3. So what is the point here? The point is that as we, so in real life, instead of getting the heights of all of the population, we take samples. And we take samples. In our case, we choose one person and we choose 2 people randomly, and we choose 3 people randomly. And what you see here is that as we increase the number of samples that we take out of the population, the average we get gets closer to the real mean, real average of the population. So basically, limit n goes to infinity. The average n and it's these are the oh wait. So as n goes to infinity, in other words, it increases, this here gets closer to the original mean, right? Because, for example, this one was mu1, let's say, mu2, and mu3. And these were the averages of the samples that we take. And so we can write this again, limit n goes to infinity. We take the average, and it is the mean of the population. And the thing is, there's one point here. Samples should be randomly chosen. And sample size should be sufficiently large. So samples should be randomly chosen. There shouldn't be any bias because, for example, let's say you only sample the people um, with small heights, then even though the sample size is sufficiently enough, it won't be a good estimate of the real of the population, of the mean of the population. So first, the sample should be randomly chosen, and the sample size should be sufficiently large to be accepted as to be an acceptable estimate of the mean of the population.